su asistencia. El día de hoy vamos a tener el gusto de escuchar la conferencia que nos va a brindar el máster Toby Clark, quien ha venido a nuestra ciudad y al ESPOL a dictar un curso de la maestría en Ingeniería Biomédica. Ya, el profesor Toby Clark es codirector del Centro Colaborador para la Gestión de Tecnologías Sanitarias de la OMS, Organización Mundial de la Salud. Es profesor de los departamentos de Ciencias Biomédicas y de la Salud y también de Ingeniería Eléctrica y Biomédica en la Universidad de Vermont, en los Estados Unidos. Además, es director responsable de un programa de gestión de tecnología de atención médica de más de 30 hospitales que cubren alrededor de 75.000 dispositivos médicos. Entonces, para nosotros es un honor tenerlo aquí, profesor Toby Clark, y la pantalla es suya, por favor. Gracias.
Muchas gracias, Professor Rapport. Many thanks to you, Professor, for inviting me here, along with Professor Vaca. It's a pleasure to be here with the students, and I understand that it's also being broadcast by Zoom. So today I'm going to talk about University of Vermont, which is where I've worked for many years, and focus on research and innovation at the University of Vermont. I was the director of a group called Imf Labs, and that was very focused on developing research instruments and also devices for companies that are starting, startup companies that wanted to have an instrument built, but they didn't have the capabilities to do that. So first of all, Vermont, mucho frío. But I show pictures of very nice summer and fall seasons. So we are a very old university, 1791, very old. We don't have as many students, I'm sure, as ESPOL, 16,000, but we have the programs at all levels, bachelor, master, and doctorate. We have this College of Medicine. We have Biomedical and Health Sciences. We have most of the disciplines that you normally would have at a public university, which University of Vermont is. We also have a College of Engineering and Mathematical Sciences. There are 600 or 700 people that are in that part of engineering and mathematical sciences, so that includes electrical and biomedical engineering, mechanical engineering, civil engineering, environmental engineering, computer science, and mathematics. I'm going to focus on electrical and biomedical engineering, which is the program that I'm teaching in. So let's talk about research and innovation. So the focus areas of research have been on cardiology, neuroscience, complex systems, which could be many different areas that are complex systems, everything from the weather to the human body. Also, we like to be known as the environmental university. So we really focus on the climate, the environment, renewable resources, etc. We also have a business school that focuses on economic development and business engagement through entrepreneurial programs. So when I was directing departments at the university, which ended about 5 years ago, my supervisor was the vice president for research. And right now I just want to mention the vice president is Kirk Dombrowski, who's done a fantastic job since his time there. And reported the first time that we've been at $250 million of research funding in 2021, which is an increase over the previous year. Many of the awards, 40, are over $1 million US, and the medical school receives the most funding, over 100 million. So for the first time, we were among the top 100 public research universities in the United States. But more than just research, we also, in the research area, focus on cooperating with companies, corporations, small companies. At the same time, internally, we want to take ideas from the university and make those into economic benefit for our state. Vermont is a state in the United States. So two things. One, we have a innovations group that is involved in supporting getting ideas patented through the patent office. Most of those are US patents, but some are global. And transferring technology from the university to the private sector so that it can be a benefit to the consumers. At the basic level, we also support entrepreneurship. So we want to support new companies, both at the university through the research, but also in the community and state. So conceive, build, launch, and then scale up. Here's an example from the electrical engineering department. A company was formed called Packetized Energy. So there was 3 electrical engineering professors who did mostly academic research on the National Electrical Distribution System. They received the highest level of grant, which allowed them to start a business, a startup company called Packetized Energy, which was recently acquired by Energy Hub, which is a largest provider of distributed energy resource management solutions. So this benefited the professors, the students that work with the professors, the university itself, because they've formed this enterprise, both from the standpoint of money, but also status, showing that they're contributing to the state of Vermont and the nation. So some details on the Packetized Energy is basically it's primarily software that maximizes the grid service value by collecting data from many sources, looking at things such as the market, the carbon prices, the renewable availability, and distributed systems needs to optimize the electrical grid. So in terms of the electrical and biomedical engineering, primary push on biomedical engineering started about 6 or 7 years ago. And the biomedical engineering is part of electrical engineering. It formed there. And again, all the levels, bachelor's, master's, and doctorate. And all the levels are ABET accredited. I've seen signs here at ESPOL about the importance of ABET. So there's been 3 focus areas. One is biomechanics, instrumentation, and sensors. Dr. Yapor is, of course, very involved in those areas. The second, biophysics, biomaterials, and transport phenomena. And lastly, modeling biological systems and analyzing signals. So there's a focus kind of on the biomaterials primarily, tissue engineering, the computer side of things, modeling, and of course, instrumentation. And these are some of the research laboratories at Electrical and Biomedical Engineering. These are all biomedical engineering labs. There's focus on neuroscience. So there's a brain lab. Sensors are MSense research group, which is primarily wearables that you would utilize. Studies are being undertaken looking at physiological signals and other signals versus conditions, patient conditions and environmental conditions. Biomedical nanotechnology and biomaterials, musculoskeletal imaging and orthopedic biomechanics. This was probably one of the earliest areas of focus by University of Vermont. And also vascular biology and reproductive science. So the chair of the Electrical Biomedical Engineering Department just recently changed to a woman who started out as an electrical engineer and then received her doctorate in physiology. And it's a good person to have as chair of the department. In fact, she took a class with me back in the 1980s. My primary area of focus is something called clinical engineering. So in 1973, actually, we started a shared clinical engineering service for hospitals and clinics. So a shared clinical engineering service. Clinical engineering is the application of engineering to the technology that's in the healthcare system. This would be everything from the assessment of the technology to see if it's effective to the disposal of the technology and everything in between, maintenance, etc. So it's a nonprofit but income expense department. Currently responsible for about 80,000 medical devices. We have 55 engineers and technicians. We actually have more technicians than engineers, primarily because a lot of the work is maintenance. So about 35 hospitals and 400 doctors' offices, physical therapy, schools, universities, and other healthcare facilities. So this is my favorite clinical engineer, Wally Elliott. He, not only was he the clinical engineer, but he was also responsible for the linear accelerators in the radiation therapy department. And that is a very complex equipment. So I was going to break off and go a little bit into the international work that the Department Technical Services Partnership has done. We have worked in a number of advanced clinical engineering workshops that were sponsored by the Pan American Health Organization. Also developed initially bilingual courses, Spanish and English, working with universities in Peru and Colombia. Patient care equipment and advanced medical equipment systems, which is basically the course that I'm teaching here at ESPOL. So a number of these universities, along with one in Argentina, are offering these courses, and of course the Pan American Health Virtual Campus for Public Health. So another course that was developed was Healthcare Technology Planning and Management. So this is not quite so much of a technical course, but more planning and management for the technology. And it resulted from the advanced clinical engineering workshops. So we talk about the best practices over the entire life cycle of technology. So the course has been taught a number of times, several times before 2020, but 2021, this course, all these courses have been now translated, the courses that I showed before in this course, to not only Spanish, but also French, Portuguese. And we recently taught the course for Haiti in French. So one of the support person that I'm working with on the advanced medical equipment course, Rosanna Rivas, she's also fluent in not only Spanish but French. So she was one of the tutors or one of the teachers of the course for Haiti. Probably one of the more enjoyable aspects of the international work is to work with engineers from other countries. We haven't had one from Ecuador, but Colombia, Peru, the Caribbean, Trinidad, Tobago, also Argentina, have come to University of Vermont for a period of time, usually 6 months, and we would train them and pay them to work. They would be responsible for travel to the US and also their lodging and meals. And you can see here, it's a University of Vermont student on the left, and Vadisha Peru, that's her name, on the right, who is from Trinidad and Tobago, working on the ventilator. So in 2017, we became a collaborating center with World Health Organization, and we're really the only one in the US that's focused on health technologies. Specifically, more the medical devices. A lot of the activities are training and education, but we also can serve as a consultant to Pan American Health Organization and World Health Organization. And generally, we can cover anything in this diagram of planning and management of health. This is kind of the life cycle of healthcare technology, from the point where it comes in the system, the request, evaluation, replacement, budgeting, acquisition, and then the bridge to management, education, compliance with standards, regulations, maintenance, safety. And the information in the gray outside is the collection of data that you need to be able to do this. So right down to the elimination of the device from the system, which also has to be planned. So I'm going to talk about this area later today at a different location. But I wanted to focus on the Imf Labs. This has been at our university for many years. It's a central, UVM is University of Vermont area for, started out with only research instrumentation development. So report to UVM research, provide all types of technical services, but also support the Vermont economic development through working with emerging technologies companies. So I wasn't associated with this group as long, but over 20 years. And the department structure is, as was the previous department, technical services partnership, is what they call income expense, which basically means we have to pay our way to be part of the university, but we still have to be not-for-profit. So we charge by the hour, we give a quotation, and the people that we work with come in either at all different levels. We may have somebody, say, from the art department that has an idea in their head. They have a piece of paper and they make a diagram that's not engineering at all, and we take that and make it into an instrument. Or it may be from mechanical engineering, so we get a CAD file. So the areas of focus of the Imf Labs have been mechanical, electronic, optical systems. This is a photo, and you can see the nice, this is in the autumn of the year, and we have a beautiful maple tree that is probably in maybe 1 or 2 weeks, it'll be like that. There's the machine shop, the automated machining equipment. We have a small staff, myself and these 3 gentlemen that have focus on various areas. Guy Kennedy is the optical expert, and he has a tremendous amount of expertise. Carl Silber is probably the best machinist in our state. He also is a fantastic designer. And Jake in the upper corner, he is a kind of a systems engineer. He knows so much about SolidWorks and systems design and networks and also mechanical. So have to be very, very good at all those. So these are some of the mechanical systems that we built. The one in the center was probably the most precise and the most detailed. That's for electromagnetic positioning systems. So you can see that the device is mostly made out of kind of a plastic or phenolic material so that it won't cause problems with the electromagnetic sensors. You know, some of the other apparatus developed to create pressure, and trying to think of what that one was. All these are used for research purposes. Parts are another thing that many times has to be made, whether it's made out of stainless steel or brass or plastic. Those parts need to be fabricated. And then the electromechanical systems. This is a bed for a physical therapist, an incubator. We modified it to put a place to put the oxygen and the gas cylinders. Also the cart that it goes around on. This is used in an ambulance. And the last is a kind of a product that we make, probably the best in the world for making arteriographs. They're used to measure vessel characteristics. We've made many hundreds of those. Some other systems, the one here with the blue monitor is part of a system that a doctor came in, said, I have a device that I want to design. I want it to be commercial. And what it did was, when people get shot in the chest, they need to have a tube put in their chest, a thoracic tube. And that tube was invented over 100 years ago. So he wanted to put in a new tube that had drug delivery, capability of not only suctioning, but also being able to create the proper pressure in the thorax. So this is just part of that system. The should we call it mannequin on the bottom was, this was an interesting project by the orthopedic department, was trying to measure the forces related to anterior cruciate ligaments in the knee, but they had to do this in the magnetic resonance imaging suite. So the magnetic resonance imaging is a huge magnet that will, again, cause problems with the ferrous metals that are in there. So we had to determine how to make the right movements. This apparatus at the foot of the table there had to work in a certain fashion. So it was an interesting project. And the other was another calibration device. So in terms of 3D printing, we had 3D printing for quite some time. First, we had something called a polyjet printer that was actually very versatile because it could make both rigid parts and also flexible parts. And it was very accurate. It could make models, it could make parts, it could make molds that you would then use to make another part. But the material that was utilized was very expensive. You had to have these liquid materials that would be used to create the hard structure, and they were very expensive. But just one story about the skull on the right. And we have a museum, and in the museum is a mummy. And the historians, archaeologists, thought that the mummy maybe was murdered, but they wanted to find out. So what they asked was that we go to the radiology department, ask if they can take CT scan of the mummy's skull, and then us making the model of the skull. So that's really a challenging thing because the mummy is very dense. The brain, of course, is very dense after thousands of years, and it's a completely different density than a person's body, which is mostly water. They finally figured out how to make the computed tomography system work with the mummy, got a good image, and then we fed the image into the 3D printer, and sure enough, on the top of the head was cracked. Somebody had hit the top of the mummy's head. In the left corner, this is our newer machine. It's carbon fiber, and it's also much less expensive to make parts. Probably the most significant thing we've done recently, this is Carl Silver, is to make an emergency ventilator. In March 2020, one of our engineers, professors, said, we need to make an emergency ventilator. This is my area of expertise. So he came up with a novel design for a very simple emergency ventilator. So Carl took that and put it into a package, and it's called the Vermonterlator. And it was, very successfully produced. Unfortunately, it didn't pass through the US FDA, but it's used in other countries. So students, of course, are part of the work that this instrumentation and model facility does, Imf Labs. The engineering program has, for the bachelor's level, when you're in our country, it's only 4 years, you do a senior project. And, that senior project may involve fabrication. So those projects, initially were done in the laboratory at Imf Labs, but we just didn't have enough space as the engineering students became more and more and more. So now, many times, we will make the parts and pieces for the students based on their design. This, for instance, is a MakerBot printer that we modified to be a bioprinter. Very, very primitive bioprinter. This is the first model. So it was, the students got to design something, modifying, a simple MakerBot printer. It's just very small, 3D printer. Also, you can see the robotic arm. And in the top, this is something that's used to hold your snow skis, but it's a good idea. Basically something that goes over your door and you can put your skis on it. This was a really fun activity which involved the community in Vermont. Something called Pitch It, Fab It, which means, basically you have an idea, give a presentation, you only have a little bit of time, and we'll have a vote. If you're selected, the Imf Labs will build that device. So there was an award for services, and this has been ongoing. Interestingly enough, my son is the guy with the hat in the top. He was one of the judges because he has a company in Vermont. But various projects came through, everything from a simple instrument that basically produces kind of a smoke from perfume type aromatic solutions that also has a color component, something that people would use in like the bars to kind of create an environment. And the company ended up being fairly successful. This picture here is of an apparatus that basically takes plastic bottles and grinds them up and makes them into just very small pieces. So last is an example from the hospital, because we have two departments, the Technical Services Partnership, which is the clinical engineering, and then we have the Imf Labs. They're in the same building, we're together. And we were having a problem with damaged equipment at our teaching hospital for the medical school. And you can see we monitor by each quarter things such as failure, the types of repairs, whether it's the use is not proper, the maintenance wasn't done. But this shows damage, and if you look to the left, you see all the highest ones are infusion pumps. So why are we having all this damage with infusion pumps? Well, it turns out that this was the infusion pump that we were using, and it had a central brain, and then modules would be attached to it for various infusions and other functions. There was a connector that is circled that made the connection between the two, and this is a copper type connector, but external to the device. And the problem was they were constantly being replaced because of corrosion, because they were breaking, had poor reliability. We're very concerned about the patients because it would cause intermittent functioning and worse problems. So it was a design issue that the company failed to have a good, safe connection between the module and the brain. And what caused the corrosion, it turns out, wasn't during the use of the equipment, it was when it was disinfected and cleaned. When it was out of use, it would go to the department for cleaning and disinfection. And the connectors would get corroded. So we came up with a design of just a cover to be used during cleaning. So they're a kind of mirror image of the connector. And we used this soft material from the 3D printer so they would have a good seal. And this was put on during the cleaning of the device and disinfection only. It didn't stay on when it went out to the patient floor. So actually, this resulted in a patent, and that was a very small technical change, but it was very valuable. Because now, when we look at our graph, infusion pumps are there, but the level is much lower. Before, level of 7, 6, 5. Now we're at a level of 2, 1. So the number of, this is representative of the damaged devices that we found 1 year later after the installation. But probably more importantly was the cost savings, because we didn't have to do all the repairs. We didn't have to buy the parts. We didn't have to, spend the money to fix it. And we felt the patients were safer. So with that, I believe we have time for preguntas, questions. I think we have a microphone here. Have questions, it's Dr. Yapur. Well, it was, IMF is the Instrumentation and Model Facility. That was the original name of Imf Labs, but we wanted to make it shorter, and we weren't doing that many models. It was mostly instrumentation and things of that nature. You need the microphone for? So IMF is Instrumentation and Model Facility.
Is there any question, please? Other questions? No questions.
Good morning, Mr. Clark. I have a question. Is there's a specific like graduate program about this stuff, or like a specific certificate program that you do to instruct young people with all these thematics?
Well, in terms of the clinical engineering, we, of course, work with the university biomedical engineering, typically undergraduate students, and also perhaps from other universities, possibly. We have had an international program of almost 50 that have come to the university and gone through the clinical engineering internship. So, contact me about that. I'm not in charge of it anymore because I'm mostly teaching now and working with the World Health Organization. But I can, interestingly, the person who took over for me was my student, then my intern, then staff member, then the associate director, and now he is the director. And I'm retired from the department. But if you want to contact me, you can, anybody.
Thanks.
Gracias. ¿Alguna otra pregunta? I'm going to speak in Spanish. I'm sorry, Toby. Más bien quisiera es hacer un resumen de lo que hemos escuchado hoy día. Básicamente ha sido una experiencia que nos ha transmitido profesor Clark. ¿Para qué? Para que estamos recién creando el área de biomédica aquí en la ESPOL, y es un ejemplo a seguir, quizás un modelo a seguir, un modelo a imitar y ver todas las áreas en las que podríamos incursionar. Así es como yo lo veo. No sé qué opinan ustedes. Quisiera escuchar vuestros comentarios.
Hola, buenos días. Voy para darlo en español, y de ahí sí me gustaría hacerle una pregunta al profesor Clark. En Ecuador nos falta esto, definitivamente. Nosotros somos muy consumidores de ciertas tendencias de tecnología, pero nos saltamos etapas, años de etapas. Hoy están usando un equipo afuera, usan la siguiente versión, y cuando nos llega a nosotros o empezamos a adoptamos la antigua, y siempre estamos como atrasados en el tema de tecnología. Tener esta charla nos da, miren, él habla del 2011 y 2012. 2011 y 2012, o sea, estamos hablando de 10, 11 años atrás, que ellos estaban haciendo esos análisis con datos de cuántos equipos se dañan. 11 años atrás. Nosotros hoy no tenemos esa información aquí, y estamos en 2022. Entonces, cada uno desde su puesto, de su puesto de batalla, en el campo universitario, en el campo privado, estudiantil, tenemos que unirnos. O sea, tenemos que seguir teniendo este tipo de conversación, como el congreso que tuvimos hace un mes, como este tipo de charlas, y debemos unirnos, porque las personas que estamos aquí estamos interesados en este tema, y de alguna manera buscamos un cambio para llegar a algo como esto a futuro. Entonces, les agradezco por organizarlo, y muchas gracias por todo. Yeah, professors, sorry for the Spanish.
Okay.
Do you understand some words? No? A little bit? May you give us some advices how to start this kind of conversation here in Ecuador? Maybe you have experience in other countries when they start talking about this, having information and working and to solve issues. Or do you have any students from Latin America? Or how can we start going in that way? I know this speak was part of it, to start to talk about. But may you give us some advices, because we are staying here in the country trying to do that, to push forward.
Is there a particular area that you're talking about, the healthcare or the innovation, research?
In my work, it's more isolate power panels for the operating theater, energy management, like consumption, but that is my area. But since we are in this, we are trying to push all the engineers to give more, like to have more safety places in healthcare. That's our goal first,
Yeah.
because we need to start with something. We're trying to do more safe place in healthcare, in hospitals, clinics, in that.
Well, I think it starts with awareness that the people that are in leadership, that they're aware of what the problems are and what the effects can be of those problems. You know, quite frankly, in working with the World Health Organization, they typically like to work with the university because it's stable, whereas the political side changes regularly. So, it's a difficult to get things done, but, first is awareness, show, some case studies of, where you've made good progress, where you've saved, improved the safety, saved money, whatever it is, and then take that to the leadership and, show them, what can be done, especially if it's an innovation. You have to do some research to, be able to see clearly what the issues are, but also how do you think that's going to affect the leadership? So, how are engineers going to solve leadership's problems? Because, they're thinking about themselves, let's face it. And, you want to, like Dr. Yapur has, published many studies and articles that make people aware in Ecuador, what some serious issues are, electromagnetic interference, as an example. So I think the awareness is really the first step, but you have to do your research, you have to have, a good case study where you've shown, that you're able to create a positive effect from a negative situation.
Thank you. Thank you very much.
¿Otra pregunta? ¿Alguna intervención? Antes de terminar esta presentación, yo quisiera invitarlos para que sigamos con el doctor Clark hoy tarde, a las 6 de la tarde, en el SPAE, en el campus Peñas, porque será mucho más aplicado a cómo se puede trabajar con la OMS, para ver los proyectos, cómo desarrollarlos. Los invito a que estén presentes hoy tarde, ¿sí? En todo caso, Professor Clark, thank you for your presentation, and we'll see you this afternoon, okay?
Okay, well, thank you very much. Thank you all. Thank you.
Thank you. Gracias.
Muchas gracias. And thank you, Dr. Yapur.